Okay, well, we're going to get started. I'd like to introduce to you Mr. Gary Aboud. He is a physics teacher from Grosse Pointe North High School. He supports, currently, he's supporting 600 K through 12 teachers. He's not working in the classroom, but he's mentoring them. And he's doing this for Grosse Pointe Public Schools. In addition to his instructional coaching duties, he is coordinating a STEM training program for physics and chemistry teachers across Michigan this summer. His work has been recognized on many levels, but most notably, he was selected by the Department of Education as the 2014 Michigan Teacher of the Year. So I'd like to present to you Mr. Gary Aboud.
Thank you very much. That was a really warm introduction and welcome. Now, do any of you know a teacher by the name of Bobby Jo Kenyon? No? Okay. She's from the Grand Rapids area. You do know her? She teaches at Ottawa Hills High School? Is that right? So she's the 2013 Michigan Teacher of the Year, and I know she's from Grand Rapids, so I was just curious if any of you knew her. But I'm really excited to be here today, and I'm really excited to work with all of you. So as you heard, I'm a physics teacher, and I teach 11th graders most of the time, and then some 12th graders as well. So do we have any 11th or 12th graders in the room? I know, but it's still fun to ask. All right, so we need 3 people at each table. If we could get people who weren't up here before, we'd love to have that. And safely, could you make your way any of the first 12 people that we get? First 12 people, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Need 3 more. 10. Oh, not if you were already up there. Not if you were already up there. You were already up there or no? Come on up. Were you up there before? Yeah. Oh, all right, all right, all right. We're good, we're good. Okay. Come on up. Let's fill these seats. I know, you're like, where's lunch? Where is lunch, people? Come on back up. I'll bring you back up, come on. It's good, it's good. It's all good, don't worry about it. You want to take that seat? We're all good. Don't worry, you're all going to get to participate too. Okay, so here's what I want to talk with you about today. As you heard, I'm a physics teacher, and how many of you have taken or are taking physics? Yes, I love it. Did you learn about the solar system yet? No. Oh, good, then I get to teach you something new. Like it, hopefully. What's that? It is astronomy, and astronomy is actually a big part of physics. And actually, one of the things that I'd like to talk with you about today is an interesting connection to our theme of today's conference with the Brown v. Board of Education 60th anniversary decision. But first, I want to tell you a little bit about myself. So take a look at this picture. Do you recognize any familiar faces? Not Barack Obama, me. That's me in the top right. So it's not photoshopped. It's not photoshopped. But I did want to tell you a little bit about what I've been up to. So one of the things that happens when you get to be Michigan's Teacher of the Year is you join the other state Teachers of the Year in Washington, D.C., and you get to meet the president, go to the White House, and the president honors teachers in a ceremony that happened just about 2 weeks ago. It was a really great honor, and what a tremendous opportunity to meet the President of the United States and hear what he had to say. And you know what he said? He said, we need good science teachers. So I'm hoping that by the time I leave here today, you'll think I'm a good science teacher and that I'll live up to what he asked me to do. I'm hoping. All right, so here goes. I'm going to ask everybody in the audience, including our friends who are up here on stage, to turn to your neighbor. That's the person closest to you. You don't have to move very far. And what I want you to do is, if you could, try to come up with a list of all the names of the planets in our solar system. Ready? Go. Yep. All right, you've got about 20 more seconds to come up with your list. 20 more seconds. If I give you this, would you take a couple pictures and videos for me, please? Thank you. All right. Please bring your sharing to a close. Could you show me with your fingers how many planet names were you and your partner able to come up with? Show me with your fingers. Show me with your fingers. Okay. All right, so our friends up here on stage have some dry erase boards. So we're going to ask them to turn the dry erase boards toward the audience and to stand up behind them. To stand up behind them and to show them to the audience. So could you stand up behind your board, show it to the audience? Can you all read these? Okay. I see over there Venus, Mercury, Earth, Mars, Saturn, Jupiter, Uranus, Neptune. I see the same. I see the same. I see the same. Wait a minute. Did anybody come up with a different list? Raise your hand if you had Pluto on your list. Okay, this is very interesting to me. Could you tell me, I see you have a white headband on. You don't have a white headband on? Oh, okay, I'm mistaken. Maybe one of your friends has a white headband on and the light's blinding me. Why do you have Pluto on your list? Because it was a planet or it is a planet?
Well, that's what I learned in 5th grade.
Uh-oh. Fumble. So tell me, I didn't hear what you said. Could you say it one more time? We're going to bring the mic close to her so you can hear what she said.
I learned it was a planet in 5th grade.
You learned it was a planet. How many of you learned Pluto was a planet at some point in your life? Me too. Me too. Now, there's a big problem that we seem to have here. Now, as a good teacher, I try to predict what you might do and what you might think, even though I never met any of you before. You, just like I, are going to wrestle with whether Pluto is a planet or not. And interestingly enough, there's another guy who wrestled with the idea of whether or not Pluto was a planet. Raise your hand if you've ever seen any television series with Neil deGrasse Tyson. Yeah, have you ever seen him on? He does interviews on television news shows. So he's an African-American astrophysicist, perhaps the toughest field in science. Now, often what we do is we say, oh, you're really smart. You must be a rocket scientist. But do you know what the rocket scientists say when they want to tell somebody they're smart? They say, you must be an astrophysicist. They really do. Neil deGrasse Tyson is actually one of the founding people, the scientists who helped Pluto to no longer be classified as a planet. Now, whether that makes you feel good about his work or not so good about his work, it's still a fact that what he did was he restructured our model of the solar system in such a way that Pluto is no longer considered a planet. We're going to get to that in a little while. I'm glad you're asking good questions. So I want to talk today not about Pluto as much as how Neil deGrasse Tyson got to his idea that Pluto shouldn't be a planet anymore. And what he did is he took what's called a model of the solar system and he altered it a little bit based on new evidence. Now raise your hand if you've ever heard the word model before. Okay, what are some things that you think of when you hear the word model?
Like a display.
A display of some kind? What else? Okay, something that represents another thing. Anything else? Like a supermodel, like a person? Me? Clearly. So one of the things that's really interesting is when we talk about models in science, we use them to represent things that we either can't see or can't observe directly, and we make a model so that we can understand it better. For example, have you ever heard that the engine of a car is like the heart of a person? And we can't actually go in and see our heart, but we can go and see an engine on a car, and that metaphor helps us to use and create a mental model for what it must be like inside of our chests with our heart. So today we're going to be working with what's called model development and model deployment. And we're going to try to steer away from the supermodel definition of the word and look more to a representation of the word, and how a scientist like Neil deGrasse Tyson could develop a new model for the solar system that no longer includes Pluto. Is that okay? Are you all ready? Yeah. This group is almost ready. Could you please clear off your whiteboards, and could all of you get ready to hold up some hands? I'm sorry? You're ready. Now we're all ready. Look at that. Okay. Up here I have this little blue plastic. It's called a dropper popper. Do you know what it does? Yeah. It drops and it pops. Okay. What I'm going to do is I'm going to take the dropper popper and I'm going to drop it on the stage. And then what's going to happen next is you're going to observe. Ready? 1, 2, 3, drop. Oh, it's broken. Oh my goodness. Let's try it again. 1, 2, 3, drop. Oh, it's broken. What's going on? Are you observing? Is it supposed to do that? Let's try one more time. Oh, it seems to be broken. Let's try the other one. I did it the wrong way. Maybe this one will work a little bit better. The blue one worked well on the carpet, so maybe this will be better on the solid. Oh, seems to be broken. I don't know. It's very interesting. Let me try with a little more force. Oh, it seems to be broken today. Maybe on the carpet is what I heard. That's a really good one. Why do you think I should do it on the carpet? Wait. So you said that because I told you it worked on the carpet, you think it should work again on the carpet. Raise your hand if you would agree with our friend on stage. Okay. What you are doing is you are doing what's called model deployment. You're taking a mental representation of what happened in the past and using it to predict what will happen in the future. So let's see if it works on the carpet. Ready? 1, 2, 3, go. Oh, it doesn't work on the carpet. I don't know. It's like stuck. 1, 2, 3, go. Oh, it's stuck. Weird. Okay. It's supposed to drop and pop. So it's only half effective. All right, but what's interesting is that our friend on stage picked up on the fact that what we know about something already should help us to develop patterns and to be able to predict. That's what scientists do, and that's what great science students do. And that's what Neil deGrasse Tyson did in his work with the solar system. He said, let's take what we know about the solar system, and let's see if we can predict new things that should be happening. And based on properties of all the planets, he reorganized and found out that Pluto doesn't fit the mold. So we're going to try and design an experiment today very similarly, but because I couldn't bring the planets with me, I only drive a Honda, I brought some different objects that will represent the planets, if that's okay. So we have all of these little objects that represent the planets. Could the people at the tables hold them up for us, please? Hold them up so the audience can see them. Ready? Hold all the objects up in the air. If you don't have an object, we will get you one. One for you. One for you. Hold them up. Okay, I've got one right up here too. It bounces, like actually bounces. Here's the thing that I want to do with this. I want to ask us if we can, as groups, decide what are some things about this that we could measure. What are some properties about these different objects that we could measure? Could you generate a list right now? Yeah. And you in the audience talk to your partner, what could you measure about these objects? Take about 10 more seconds to generate your list. Okay. Let's get an idea of what are some of the things that we can measure. Could we hear from group number one? One thing that they said we could measure is?
Weight, shape, size, color.
Could you pick one? That's okay. That's okay. I wasn't clear. One thing that you could measure. We could measure the weight of these objects. Do they all look like they have the same weight? No. Okay. And did you weigh them? But you think they don't have the same weight? That's really observant of you. What's something else that we could measure? The material it's made out of. Okay, did you bring your materialometer with you? I forgot my materialometer. Is that a 1 or a 10? Oh, that's a 1. That's terrible. All right, so, oh, it is a 10. Thank you, thank you. One more thing that we can measure from group number 3 that hasn't been said. They said weight and the material. What? The temperature of the object. Okay. Why are you laughing? Wait. Tell us what you just said. Would you say all these are at the same temperature right now? Are they all in the room? They're all room temperature. Okay. But could we measure that? What would we need to know to be able to measure that? We need a thermometer for the room. We could do that. And what's one more thing from group 4 that we could measure that hasn't been said already? The velocity. What do you mean when you say that? How what? When it bounces. What about when it bounces? Like how it bounces? How fast it bounces? Okay, awesome. Hopefully you came up with some of the same ideas, but I really like group number 4's idea because it'll be the most fun, because we can actually bounce these. So what I need now is a new volunteer, perhaps from the audience. First hand I saw up, come on up. And you're going to stand on this side of the table with me. This is going to be something that you can all participate in, so while she's getting up here and we're getting set, could you erase your boards, please? What's that? Tell me your first name. LaJayla? DeJayla. Okay. I have like 2 microphones on. It's hard to hear things. All right, here goes. What I'm going to do is I'm going to take the ball, and we're going to try to measure how it bounces idea. I'm going to bounce it on the floor so that it hits the ground and then goes up under and hits the bottom of the table. When it hits the bottom of the table, your job is to predict what will happen next. And to make it easy, we're going to do a multiple choice. Are you ready? Choice number 1. The ball is going to hit the ground, hit the table, and bounce to DeJayla, who's going to catch it. You might want to take like 1 step back. Perfect. Choice number 2, it's going to hit the ground, hit the underside of the table, and it's going to go up and down, up and down, up and down until it fizzles out. Choice number 3, it's going to hit the ground, hit the underside of the table, and come back to me. Could you cast your vote with the fingers that you have on your hand now? 1 is bounce under and go forward. 2 is up and down, and 3 is to bounce back. We need to see fingers from everybody, fingers from everybody. Okay. Terrific. Now, for our cameras, we want them to be able to see how many people voted each way more easily. So we're going to ask hands for choice number 1, show your hands now. Hands for choice number 2, show your hands now. Hands for choice number 3, show your hands now. Hands for choice number 4. Oh, everybody's got to vote. I don't know, but they didn't raise their hand the other time, so I figured they knew something I didn't. Oh, you have a question? Go for it. I'm going to hit it on the ground, and it's going to go under and hit the bottom of the table. I'm aiming for the ground. Was I somehow unclear? I'm going to hit it at the ground. Wait. I want to make sure that I'm honoring what you're saying. So come stand next to me so you can make sure there's no funny business with how I throw it. All right. Ready? 1. Are you ready? Are you ready? Are you ready? Yeah. Not ready. Ready now? Okay, ready? 1. 2. I don't think you're ready. Are you ready? 1, 2, 3, go. What do you mean? What did I do? Wait, what do you mean I didn't throw it right? Well, okay, hold on. All right, Mr. Lipinski is going to take his seat back at the table. Thank you. Sure. Hey, sure. All right, so that clearly didn't do anything that involved you. However, we do have other objects up here. What do you mean that one will?
It will go back to her.
What do you mean? Like it'll go forward?
Like you bounce to her, you don't bounce, it will come to her.
Okay, so we're going to ask Mr. Lipinski, he's going to observe something about this ball. So could you tell us a couple of the properties you observe? It's really light. Do you think it's solid or hollow? It's hollow. Is it made of rubber or is it smooth? Like is it grippy or is it smooth? Okay, is it made of rubber or plastic? All right, so we have three properties, rubber, hollow, and smooth. Let's get one that, okay, tell us what's up with that one. Heavy. Is it solid or hollow? It's solid. Is it smooth or is it kind of, ooh, and it's grippy. So it's the exact opposite of this one. Could I see that? Thank you. So here's what I'm wondering. If this has different properties than that one, will it do the same thing or will it do something different? Could you consult your neighbor and vote now? Are you ready to catch it? Okay. Got me back here? Here? Well, I don't want to like make an accident and hit somebody. I'm a physics teacher, not a baseball player. All right. Are you ready? Let's do a vote. Oh, you have a question? Well, I'm going to do the same thing I did last time. I'm going to throw it like this. That way we are controlling, I'm glad you brought that up, as long as everything is the same except the object itself, we should be able to attribute any differences to the properties of the object itself. So, are you guys ready? What do you think is going to happen? 1, 2, or 3? All right, ready? 1 is to go through, 2 is up and down, and 3 is to come back. Could you show us with your fingers now? 1, 2, 3. What do you think? Okay, ready? What? You're ready? Okay, 1. Oh, too close. 1, 2, 3, go. Wait, what did it do? It came back. So same or different as the first time? Okay, so different properties, different outcome. Could you all on your whiteboards record this for us? We're going to make a little data table. And we're going to trade. Which one do you want me to try next? The golf ball. All right. Here's what we saw. I'm going to recap for us. The first one was hollow, smooth, and light. And it went and it did number 2. The next one was heavy, grippy, and solid. And it did number 3. Nobody laughs at that because they don't know what number 3 is. All right. Let's keep it PG in here. All right. Now we have the golf ball. Tell us about the golf ball properties, and they're going to keep track of this for us. Smaller. Okay. Grippy or smooth? Check it again. Smooth. Okay. Could you all record this? We're making the data table. This one is smaller, so it's lighter. Did you say, is it solid or is it hollow? It's solid and it is smooth. So we got those 3 properties. Light, solid, smooth. Is that okay? Now we want to see if we can predict what will happen based on the properties and based on our previous tests. So we're going to ask you all to vote now. Will it do number 1 and go through? Will it do number 2 and go up and down, or will it do number 3 and come back to me? Could you vote with your fingers now? Okay, are you ready? 1, 2, be careful, because if I miss with this one, it's a little bit more painful when it hits. All right, ready? 1, 2, are you watching? Great, 1, 2, are you ready? Are you ready? 3, go. All right, could I get that back, please? Thank you, great catch. I always like not to injure anybody during one of these. Here's what we're gonna ask the groups to do on the stage. We're gonna ask them to tabulate all the things about the different objects that we tested and the outcomes. They should have a data table for us that they are then gonna show, and we're gonna talk about it for the last minute here and make some sense of it. Can we give Dejayla a hand, please, for helping us out? Thank you very much. Okay. What we just did, and if everyone at their tables could show their whiteboards up to the front audience. They could show it up to the front audience. What we now have is a set of results. Ready? What we have is a set of results that outlines 3 different tests for 3 different objects. There were similarities in some of the properties. For example, the first and the third test, both were smooth. The second and the third, both were hollow. The first and the third, both were light. But their outcomes each time were different. So what we now have is some trend. We have a trend in our data, and what that will allow us to do is to take a new object, like this one, and based on what we know about this object, we can fit it into one of these 3 categories, and we should be able to predict what happens. So what we're going to do is we're going to ask our friend here in the vest, tell us your name. Rayshawn is going to look at this object, and he and his group are going to figure out, as well as you are, what would it do if we throw it? So hold it up so everybody can see it one more time. Hold up the object that I just handed to you, Rayshawn. Based on what we can tell about this object, Rayshawn, what do you think it will do? 1, 2, or 3? You think it'll do 2. Why? Tell us its properties. Is it light or heavy? It's kind of heavy a little. Compare it to this one. Heavy? Which one's heavier? That one? What are those 2 objects? Okay, do you know what they are? Like, what would you use them for? They're both golf balls. So are they the same or different? They're the same. What's different about them? The color. Do you think the color will make an impact? No. Okay, so then based on that, what should it do? It should do the same thing. Should. Let's test it. Would you like to help us out? Okay, Rayshawn, would you like to help us out? We're going to test this, and then we're going to wrap it up. But what we're doing is just like Neil deGrasse Tyson did with the planets. He looked at the properties of all the planets, and he found out that Pluto did not fit into any of the categories. And so he proposed a new model where Pluto has its own special category called dwarf planet. And that's why it was removed from our model of the solar system that has no 9th planet anymore. Are you ready? 1, 2, 3, go. What did it do? Same thing. So does your model predict the behavior of a golf ball? It does. So give yourselves a hand. This group's going to wipe up their boards. Thank you very much. All right, ladies and gentlemen, Neil deGrasse Tyson is the reason we don't have Pluto anymore in our solar system. These folks are the reason that we now know what a model is and how to develop it and use it. And I would love it if you could take that back to your physics classes and hopefully make it a more successful end of the year. Great to talk with you, and thank you so much for your time.